Hello everyone, welcome back to the Atharva Gate Academy. Myself Chinmay Dharup. Now today in this video we are going to start chapter 6, that is Slope and Deflection. In this chapter we are going to discuss how to find slope and deflection in beams under different types of loading condition. Fine. Let's say we have this beam which is fixed at left hand side and we apply point load at this end. So due to this load, this beam is going to be deflect like this, right? And here this is going to be the value of deflection, that is denoted by Y. And you can see that this beam is inclined at this point, right? Means it is deflected, and if we draw tangent to this beam at this point, then it will be something like this. And here this angle will be angle theta, which is called as slope in this beam. So we will discuss that how to find value of slope, that is theta, and value of deflection, that is Y, in different types of beam in different loading condition. Fine. Let's say this point is point A and this point is point B. Let's say if we apply any loading condition on this body, it may be this type of point load or this type of concentrated moment, or it may be uniform distributed load. Although we apply different types of loading condition, deflection at point A will be 0. Means Y at A will be 0 because this end is fixed. So there will be no deflection of this point. And what will be the slope at point A? Slope at point A, that is theta A, will be equal to 0 because from here this beam is going to be deflected like this. So tangent to this beam at this point will be horizontal line. So at this time this angle theta will be 0. Means remember that at fixed end value of deflection and value of slope is 0. Now let's say we have another beam, that is beam AB, and which is simply supported beam. Means at end A it is having hinge support and at end B it is having roller support. In this case, what will be the value of deflection at point A and what will be the value of deflection at point B? Let's say we apply point load P in this direction at this point, which is midpoint of this beam. So due to this load, this beam is going to be deflected like this, right? So you can understand that value of deflection at point A and point B will be 0 because these both points are not allowed to move in Y direction. Fine. And in this case, if this point load is acting at midpoint of this beam, then value of theta A and theta B will be same. Means slope at this end and slope at this end will be same. And it will be maximum in this beam at this both end. So it will be maximum. At this point slope will be 0 because tangent to this point will be this horizontal line, right? Now we will discuss methods of finding slope and deflection. Here you can see there are several methods to finding out slope and deflection. First method is double integration method. Second method is moment of area method. Third method is strain energy method. Fourth method is Maculus method. And fifth method is conjugate beam method. Now in this chapter we will discuss these first three methods and we will find value of slope and deflection in different types of beam. First of all, we are going to discuss double integration method. Now we are going to discuss double integration method, in which you have to remember this equation. Now how this equation is derived? We know that sigma by y is equal to m by I is equal to E by R, right? And let's say if this is beam and we apply bending moment like this, then this beam may be deflected like this, and here this radius of this beam will be R, right? That is this radius. From mathematical calculation, it is derived that 1 upon R is equal to d square y by dx square. It is part of maths. So if we compare these two terms and we put 1 upon R is equal to d square y by dx square, then we will get this equation, right? From here it will be m by I is equal to E into d square y by dx square. So if we multiply this I here, then we will get this equation. Fine. In this equation, this E is modulus of elasticity, this I is area moment of inertia, this Y is deflection of beam, this X is distance from origin, and this M is moment in body as a function of X. Fine. So by using this equation, we can find out value of deflection, that is Y. Now how we can find out value of deflection Y from this equation? For that we have to integrate this equation 2 times with respect to X. Fine. So if we integrate this equation, then it will be EI into integration of d square y by dx square will be dy by dx, and which is equal to integration of m into dx, and plus there will be constant, right? Now understand that this dy by dx is the slope of line, right? So here it will be the slope of beam, that is denoted by theta. So from here we can find out value of theta. To find out value of slope means to find out value of dy by dx, you have to put boundary condition in this equation, then you will be able to find out value of slope. Fine. Now if we want to find out deflection, then we have to integrate this equation with respect to x. Then it will be EI into what will be integration of dy by dx, it will be y, right? Which is equal to, now here we have to again integrate this equation with respect to dx. So it will be double integration of m with respect to dx. If we take this constant as c1, then here it will be integration of c1 with respect to dx plus constant c2. Fine. So finally you have to divide this expression by EI and you will get y, that is deflection in beam. Fine. Now we are going to solve some examples so that you will be able to understand that how to use this double integration method to find out value of slope and value of deflection in the body. Fine. Now in this example, we have beam AB of length L which is fixed at end B, and we apply point load at point A in downward direction of value P. Now in this case, we have to find out value of deflection and value of slope, and we will find value of maximum deflection and value of maximum slope, right? Here you know that value of deflection and value of slope will be 0 at this point B. Fine. YB will be equal to 0 and theta B will be equal to 0. And we also know that value of deflection and value of slope will be maximum at this point. Fine. Now how to find value of deflection and slope by using double integration method? We know the equation, that is E into I into d square y by dx square is equal to m. Here this m is value of bending moment in this body as a function of x, and we have already discussed that how to find value of bending moment as a function of x in chapter 4 shear force and bending moment diagrams. Fine. If you remember how to find out value of moment in this beam, For that, we will take section in this beam at distance of x from this point. Means here we are taking this point as origin and this direction as x direction. To find out value of bending moment, we will take sum of all the moments acting on this beam by the transverse force acting at the left side of this section. Here you can see that there is only one load acting at the left side of this section. And what will be the value of moment by this load? It will be P into this distance, that is x. And here this P load is acting in the downward direction, so we will take this P load as negative and our value of moment will be minus Px. Fine. So we are going to put this value here, then it will be minus Px. Now to find out value of slope, we have to integrate this expression with respect to x. So it will be Ei into integration of this d square y by dx square will be equal to dy by dx, which is equal to, what will be the integration of minus Px? It will be minus P into x square by 2 plus constant C1. So here this is the slope in this beam. Theta is equal to dy by dx. Now here we have to find out value of this constant C1. For that we will put boundary condition in this expression, and we know that at point B theta is equal to 0, means at this point where x is equal to L, value of slope is 0. So if we put this boundary condition in this expression, then it will be E into I into slope is 0. This, which is equal to minus P x is equal to L plus C1. So from here this term will be 0, right, and value of C1 will be PL square by 2. So now we will put value of C1 here. So it will be PL square by 2. Now to find out value of deflection y, we have to integrate this expression. So it will be Ei into y, that is integration of this dy by dx, which is equal to, what will be the integration of minus p x square by 2? It will be minus p x cube by 2 into 3 will be 6, plus integration of this term will be PL square by 2 into x, plus there will be constant C2. Now to find out value of y, we have to find constant C2. For that we will use another boundary condition, that is yb is equal to 0. Means at this point where x is equal to L, value of deflection, that is yb, is 0. If we will put this boundary condition here, then this y will be 0 and we have to put x is equal to L. So it will be, this term will be 0, which is equal to minus PL cube by 6 plus PL, here there is L square and we are going to put x is equal to L. So it will be L cube divided by 2 plus C2. Now here you have to take PL cube common, and if you will simplify this, then you will get value of C2 is equal to PL cube by 3. Fine. Now we will put this C2 here. So it will be PL cube by 3. Fine. Now here we have these two equations. From this equation we can find out value of theta, that is dy by dx, which is slope in the beam, and from this equation we can find out value of deflection, that is y, and we can find out value of slope and value of deflection at any point in this beam. For that we have to vary value of x. If we want to find out value of deflection at point B, then we have to put x is equal to L. If we want to find out value of deflection at midpoint of this beam, then we have to put x is equal to L by 2. And let's say if we want to find out value of deflection and slope at point A, then we are going to put x is equal to 0 because at point A x is equal to 0. And if we will put value of x is equal to 0 in this expression, then here this term will be 0. And from here dy by dx, that is slope at point A, which will be equal to PL square by 2, and this EI will be multiplied with this 2. So it will be PL square by 2EI. Fine. And what will be the value of deflection y at point A, where x is equal to 0? For that, we will put x is equal to 0 in this expression. So this term will be 0 and this term will be 0. And here this EI will be multiplied with 3. So YA means deflection at point A will be equal to PL cube by 3EI. So I hope that you understand how to find value of deflection and slope in beam. First of all, you have to use this equation, and in this equation you have to find value of moment as a function of x, and then you have to integrate this equation with respect to x 2 times. If you will integrate this equation with respect to x once, then you will get slope, that is dy by dx, and by integrating second time you will get deflection. And in this equation we have to find out value of constant, that is C1 and C2, by putting boundary condition. Fine. And one more thing, that this y, that is deflection, will be equal to integration of theta with respect to dx. Fine. If we will integrate both the side, then we will get this. Means we can say that integration of slope with respect to x is deflection in beam, and derivation of deflection with respect to x is value of slope in beam. Fine. So I hope that you understand how to find value of slope and deflection in the beam. Now we are going to find value of slope and deflection in this beam. Here we have beam AB of length L, which is fixed at point B, and we apply uniform distributed load W over this beam. In this case, what will be the value of theta and y? That is slope and deflection. Now to find out value of slope and deflection, we are going to use double integration method. And we know that equation to find out slope and deflection in double integration method is EI into d square y by dx square is equal to m. And here this m is bending moment in this beam as a function of x. Here this point is taken as origin and this direction is x direction. We have discussed that how to find value of moment as a function of x in chapter 4, shear force and bending moment diagrams. In that chapter we have found that m is equal to minus wx square by 2 for this type of beam. Fine. If you have any doubt how to find value of bending moment in this case, then you can watch that lecture. Fine. Now here I am going to put this bending moment here. So it will be minus wx square by 2. Fine. Now to find out value of slope, we have to integrate this expression with respect to x. So it will be EI into dy by dx, that is integration of d square y by dx square, which is equal to integration of this term, that is minus wx cube by 6, plus there will be constant of integration. Let's say this constant is C1. Now in this case we know that value of slope and value of deflection will be 0 at point B. So we can write that yb is equal to 0 and theta b is equal to 0. And if we put this condition here, then we can find out value of C1. From this condition we can say that value of slope at point B is 0 where x is equal to L. So here this dy by dx, that is slope theta, will be 0. So it will be 0, which is equal to minus w x will be equal to L. So it will be L cube divided by 6 plus C1. So from here we can find out value of C1. It will be WL cube by 6. So if we put this value of C1 here, then it will be WL cube by 6. Fine. Now we are going to find slope from here. For that we are going to integrate this expression with respect to x. So it will be EI into y is equal to integration of this term, that will be minus w x raised to 4 divided by this 6 into 4. So it will be 24 plus integration of this term will be WL cube by 6 into x plus there will be constant for integration, that will be C2. Now to find out value of C2 we have to put this boundary condition. At x is equal to L means at point B value of deflection YB is 0. So we can write that y will be 0 and x is equal to L plus WL, here there is L cube and there will be L instead of x, so it will be L raised to 4 divided by 6 plus C2. Fine. From here if you will find value of C2, then C2 will be WL raised to 4 divided by 8, right? And now we will put this C2 here. So it will be WL raised to 4 divided by 8. Fine. So now we have these two equations. By using that we can find out value of slope, that is dy by dx, and value of deflection, that is y. Let's say we want to find out value of deflection at point A, where value of slope and value of deflection will be maximum. So for that we will put x is equal to 0. So if we will put x is equal to 0 here, then this term will be 0. So from here we can write that theta, which is equal to dy by dx, will be equal to WL cube by 6, and this E into I will be multiplied with 6. So it will be EI. And if we want to find out value of deflection y, then we will put x is equal to 0 in this expression. So this term will be 0 and this term will be 0 because this x is 0. So we can write that deflection will be equal to WL raised to 4 divided by 8, and this E into I will be multiplied with 8. So it will be E into I. So now we have slope and deflection, that is maximum slope and maximum deflection in this beam at point A. Fine. Here this slope is slope at point A and this deflection is deflection at point A. I hope that you understand how to find slope and deflection using double integration method. In the next video we will discuss other methods to find out slope and deflection. Now today we will stop here and we will continue in the next video. Till then, stay motivated and happy practicing.